Welcome to this video. In this video we will see what is heat treatment and heat treatment types. So heat treatment is a heating and cooling of metals or alloys in its solid state to get the certain characteristics of material. We get the characteristics like hardness, ductility and toughness. So by heating and cooling in its solid state only, we get these properties, and this process is called as heat treatment. We have various heat treatment processes, and the type of heat treatment processes are: first one is annealing, in which we heat the material and then cool in the furnace, so it is called as furnace cooling. First one is annealing. The second is normalizing, in which we heat the material and then cool it in the air. Third one is quenching, in which we first heat the material and then we dip it into the water or oil bath, so it is a water or oil cooling. The fourth one is tempering, and the fifth one is diffusion. So we will see these all processes in separate videos in detail. Here the further classification of this process I have mentioned. So in annealing, it is a heat treatment process in which we relieve the stresses and we improve the ductility. We'll discuss this four processes: full annealing, stress relieving, process annealing and spheroidized annealing in detail in separate video. Here I have mentioned the temperatures, which is in full annealing we heat the material above upper critical temperature, which is 910, and then we cool it in the furnace. In stress relieving, we cool the material 0.4 times the melting temperature of the material, and then similarly we cool it in furnace. In process annealing, we keep the temperature below lower critical temperature, which is 727. So lower critical temperature is 727 degrees Celsius and upper critical temperature is 910 degrees Celsius. We will discuss periodizing process in detail in separate video, where we cool it in furnace, but there the graphite flakes, which are like needle structures, microstructures which are like needle, we convert it into a spherical spheroids, which are more ductile in nature. So we will discuss these processes in separate video. In normalizing, we cool material in air, but first we heat the material above 910 degrees Celsius, which is upper critical temperature. So we get more ductility in annealing because it is furnace cooling. It is very slow cooling by controlling the temperature in the furnace. So this annealing process has more ductility than normalizing process. In quenching, we cool it in water or oil, so it is very sudden cooling and material is often very hard and brittle. We'll discuss this more in next video. So tempering has a three categories, which is low temperature tempering, medium temperature tempering and high temperature tempering. In tempering, we just have to relieve the stresses which are obtained in quenching or normalizing. So in quenching, we get a very hard and brittle material. Just to relieve those distortion stresses and to have some ductility with the brittleness and hardness, the tempering process is introduced. Here we have three separate tempering temperatures, which are the three ranges from 150 to 250, which is called as low temperature tempering, and medium temperature is 350 to 450, and high temperature tempering is 500 to 650. So in the more the temperature, the more will be the stress relieving and the more will be the ductile introduction into the material. So these three has separate applications, and they are differentiated based on the temperature range. We'll discuss tempering also in further videos. And diffusion process, here the primary goal is to introduce the foreign element like nitrogen, carbon and boron and also have some flame hardening and induction hardening processes, in which we either heat the surface or introduce some diffused material inside the surface, which brings more hardness into the surface. So this all are the hardening method which is introduced by the foreign material inside the steel. Now in nitriding, the temperature is about 600 degrees Celsius, and we heat our steel material in the atmosphere of ammonia gas. So the nitrogen will diffuse inside the surface, and which will prevent the motion of dislocations, and also it will create the hindrance in the grain boundary movement and also dislocation motion. So that way it introduce the hardness and brittleness inside the material. In cyaniding, we heat at about 850 degrees Celsius in the molten salt of NaCN. In flame hardening, we just heat the material with a high temperature flame at about 2400 degrees Celsius and above, and we suddenly quench it so that there is a hardness introduced inside the surface. In induction hardening also, we heat the material with the electrical coil, and due to eddies of the electrical current inside the material, there will be heat generation inside the material. We quench it into the water, so that's how the surface is hardened of the material. And in carbonizing, we heat our steel sample with the charcoal, and the carbon is introduced inside the surface of the material. And in boronizing, we heat the material with boron gas or some solid compounds of boron at about 900 degrees Celsius, and this gives extremely brittle and hard surface. So these are the hardening methods, and all these 5 methods are for steel, which is important to get the characteristics which we desire, like hardness, ductility, toughness, and surface hardness. So we'll discuss each and every method in separate videos. And if you like this video, then please hit the like button and share if someone is preparing for competitive exam. And these are the basic concepts which are asked in major interviews of ISRO, DRDO, and BRC. And these are also some of the questions which are asked in UPSC Civil Services optional mechanical subject. And it is a very important topic in material science, through which we get different properties of material. And see you in the next video. We'll discuss all these methods in detail.